Uh, Hello all. We are going to explain the next concept in our operating system is process concepts. So this is a continuation of the previous one. So in this process, this is session 6. So the process concepts we are going to discuss about what is process and what is PCB, and if you are creating a process, how the memory structure will be, and the process states. Okay, so here we are going to discuss two types of states. One is the 5-state model and another is the 7-state model. Okay, right. So what is a process? So under process concepts, we are first going to discuss what is a process. Okay, so initially the task will be divided into with the computer related task and the user related task. Okay, so in generally the task we are naming as what batches. Okay, and this batches or the task are the two types. One is the user related task and the system related task. Okay, so in books we will be using sometimes we will be using as job, and sometimes it will be mentioned as process. Okay, so what is a process? So process is a program in execution. Okay, so what is a program then? The program means whatever user providing the task or the system providing any task, so that is called as what? Program. Okay, so the program which is under execution, it is called as a process. Okay, so the process execution must be in a sequential way. So program means what? The task is created. So once the task is created, then that new created task is called program. When the program started its execution, then that point of time it is called as what? Process. So when the process will start when the program will be converted into a process, so already we know that so when we are having the program, okay, so after the compilation, after enters into the assembly, and then by using the linker and the loader, what will happen? It will go to the main memory. It will be loaded in the main memory. So in the main memory only, what will happen? We will be having the exe file. Okay, so when this exe file started its execution, so that time what will happen? The program is converted to a process. Okay, the program is converted into process. Okay, so so when we are doing when it started its execution, how the content will be available in the memory. Okay, so before that, okay, so before that the program which is not started its execution, it is called as a passive program. Once it started the execution, then it is called as what? Active program. So these are the two terms also we are using. So when it's stored in the memory for a process, these are the informations will be available: stack, heap, data and text. Okay, so stack is used to store the variables which we need. So whatever data we need, that will be available in the stack. And heap is going to support the dynamic memory allocation. And data, what are the local data we need for executing the data, that will be available in the data section. And text is the comments. So the comments are again what are the other informations we need for executing the data. So all these informations will be available in the text part. And then this is an important thing, process control block. So what is the use of this process control block is, it will provide or it will maintain the information for each and every process. Okay, so by using the fork system call, once the process is created, what will happen? So the unique process ID will be created. Along with the process ID, the status to store the information. So here this PCB will be created. So the PCB consisting of process state, process number, program counter. So from which address to which address the particular process needs to be executed. Okay. So what are the memory limits? So what are the other open files needs to execute this process? Okay. So all the things will be maintained in this PCB. Okay. Process control block. Another one is the process switching. So we will be using two terms, CPU switch and the dispatcher. Okay, so CPU switch means, or we can call it as a processor switch, means when the processor moves from one block to another block, or the processor moves from one process to another process, then it is called as what? CPU switch. Okay, then dispatcher. What is dispatcher means? When the program moves from one state to another state, means, so that will be done with the help of the dispatcher. Okay, so here we are going for CPU switch. So what is CPU switch? So for example, if one process is doing its execution, so process 1, okay, process 0 is executing. Okay, so that time the process P1 comes with the highest priority. So what will happen? The PCB states will be saved. Okay, and then once the save conditions are saved, what will happen? The program process, that is process P1, will start its execution. Okay, so reload the state from PCB1. Okay, again, if there is any interrupts or happen in between the execution of PCB1, means what will happen? To service the interrupt call, the PCB1 state, this process 1 states will be saved in PCB. Okay, and then the executions will happen. So once the PCB, that is process 1, completed, what will happen? The process 0, again it will reload it and it will start do the execution. Okay, so this is the movement of processor from one process to another process. So this movement from one process to another process, it is called as what? CPU switch. So next we are coming for the process state. So initially, before going to the 5-state model, so this is actually the 5-state. Before that, we had 2-state. So in 2-state, we will be having the ready state and the running state. Okay, so only the program or the process will oscillate between the ready and running. Okay, so we don't have much information if you are having only 2-state. So because of this, from 2-state we are going to this 5-state model. Okay, the 5-state we will be having new, ready, running, waiting and terminated. Okay, so if any process ready with the resource, so it will come from new. So new, in the new state, the new process which wants to get the CPU, that will be available in the new state. Once all the resources are ready and the process is come to the ready state and waiting for the CPU time, once the CPU is free, what will happen? From ready state, the process will go to the running state. If any high priority job is coming, means what will happen? The process will move from the running state to the ready state again. If the process needs any resources, so what will happen? From the running state, it will go to the waiting state. Once the resources or any IO operation it needs to be executed, so everything is done, means again from waiting state it will go to the ready state. From ready state again it will go back to the running state to get the execution. Once it is completed, it will come to the exit state. Okay, so here we get the clarity of how each and every, how the process moving from one state to another state, and also it's showing when the process moving to the waiting state, for what reason it's moving to the waiting state. Okay, but what will happen here in one here in this case, one major drawback is here is, so here all the things during at this time, the process will be allocated or available in the main memory. So that time any job wants to get execution, means, so if the memory is not available, means what will happen? The process, even though the process ready with all the resources, instead of the memory is not available, it will not come for the execution. Okay, so that is a main drawback. To avoid the drawback, we are coming for this 7-state model. Okay, so in the 7-state model, in the 7-state model, in the 7-state model, we are having the blocked, waiting and suspended. So what will happen up to the ready, running and waiting, the same process will be happen. What I discussed in the previous state. But here what will happen if any process waiting for its IO operations for a long period of time. So what will happen? The process will move from the waiting state to the suspended state. So basically what is happening here is the content which is available in the main memory, when the process enters into the suspended state, the content will be moved from the main memory and it will be loaded into the secondary memory. Okay, so once the corresponding event is ready or occurred, what will happen? From the suspended state, the process, it will enter into the ready state. So that time the subroutines which are moved to the secondary state, that will come to the main memory again and it will start do the execution. Okay, so this is the more advanced concept of thing, so that the memory is also effectively used. So the process which is not currently running, that will not stay in the memory, so that place can be utilized for the new process doing its execution. So these are the process state model. So the remaining concepts, the next concept we will discuss about the CPU scheduling, everything in the next class. Thank you.